Hello, and welcome to another FHIR for Developers tutorial video. My name is Gino Canessa. Today we are continuing on our journey through profiles and validation. We're going to pick up where we left off on validation using Fluent validation. And we had built up that US core patient validator. Now we're going to continue that into vital signs and blood pressure, just like we did when we were doing our creation. We want to do the same thing for validation and see some of these extended rules and how they work. So with that said, there's a lot to do. Let's jump right in. Here we have our program where we left it last time. I did do a tiny bit of cleanup that's been pushed up, but nothing relevant. And we want to do, like we did last time, just a tiny bit of refactoring before we do this. And I think what we want to do is do a quick private static bool validate. We should be able to do validate resource. And this is just because we're going to switch this up and not be using patient. And we don't really want to keep replicating this code over and over again. In here, we should be able to pass in a resource. And let's not worry about making this quite so generic. I realize that we're going to have problems because the Fluent validator is tied to patient, and so we need to make sure that if it is a patient, we can use that one. And with the generics, it might cause some issues. And actually, we can change that by doing something like this, I believe. And we can do T resource, and we can do, what is this? This is an abstract validator of that. So I think we can do something like this. Will it let us do this generic? Let's do that just so it doesn't yell at us. And here we'll just return false first, just to see. And so now we should be able to do something like, and let's see if this works. Let's take all of this code and put it here. We're actually going to do this because we're going to add another parameter here in a minute. And we're going to grab our validator and say validator.validate. And we want to return validation result.isValid. So validate a resource against a Fluent validator. So in theory, we can do something like, and this is not necessarily optimal. Probably it would be better to just pass in the two types and put different restrictions on there, but this should work well enough. And what we can do here then is do something like validate resource with patient, and we can pass create patient and new US core patient validator. Perfect. So we can do it this way. We can also, change this to be a resource so that we can do this and get rid of all of this. Perfect. This is much better code because now when we want to do this, we can call this patient and patient, for instance, and that makes sense. This will make it easier since the next thing we want to do is make an observation. And what did we say? So create observation. And we're going to want to do the same thing here, that we can do a validate resource, an observation, and we don't have anything passing. So That's a much nicer format just for here while we're testing. So we can comment that out because we don't care about it right now. And then we can look in our validation. So right now we have this US core patient validator, and we know the next thing we're going to need is a US core vital signs validator. And the reason we know this goes back to the same thing that we've gone through before. What we really want to validate is this blood pressure, but blood pressure starts from US core vital signs. So we need to make sure that these rules don't show up here. And so we want to make sure that these are met before we even worry about the other ones. So just getting ourselves set up before we dig into anything, all I'm going to do is make US core vital signs validator class and copy everything from the patient validator. And then we can just do things like this. We don't have to worry about data absent reason or anything where this is. We're going to validate observation objects against US core vital signs. We definitely need this URL to replace our patient one. And then, oops, this is a US core vital signs, and this needs to be an observation. Perfect. So we don't need to worry about what's in here at all, and we don't need to worry about US core 8. Perfect. We'll save that, and we have our basic US core vital signs validator, which does absolutely nothing. So what rules do we have here that we're interested in? Well, most of these rules are actually just these must support flags. So you can see that the US core vital signs adds a lot of must supports. But you can see that most of the fields are grayed out. So we talked about this before, that when we're reading the profile, the grayed out versions, or the grayed out fields, mean that there is no change. And so most of these things, when we talk about must support, there's really nothing for validation. Must support just says that you have to do something with that value if you're doing things. In this case, we're not really doing anything, we're just validating. And so whether they're present or not, or what those values are, we're not interested in. The big one here is this category. And this is a codable concept that's sliced to do this. Now, slicing, I think we talked about a little bit. Did we actually talk about during patients? Now I have to remember. I don't think we did because it didn't have any slicing. Correct, we did not. Okay, just trying to remember what we've talked about here, apologies. So slicing is in FHIR the way of describing, constraining given elements of an array. And there we go, it's in profiling. So again, I'll add this link to the GitHub repo, but this whole thing about profiling talks about a lot of things, but in particular, slicing. And you can see, look, blood pressure profile even shows up here, like it's a common example. And so what we're going to do is, we can see there's this thing called a discriminator, and there's a few different ways that you can slice things. So you can slice things on a particular value, whether they exist or not, based on a pattern, based on their type, based on their profile, all these different things to control what elements of an array need to exist or things like that. So in this case, what we're saying is category is sliced. It's unordered, so it's not that a certain element has to be the first element or anything like that. It's open, which means this isn't the final rule in the chain that nothing else can be applied. There can be more rules after this. And then it's sliced by value on these two things, coding.code and coding.system. So again, if we jump back, we can see slices have different values in the nominated element. And I think we can click through here and get, oh, now that just brings us right back to where we are because it's right here. So all it's really doing is saying we need to have a slice that has a coding.code matching vital signs. And we need to have a coding.system which matches this code system URL, the observation category. So within this particular coding, because that's an array, you can have as many as you want. Within this category codable concept, you can have as many as you want, because again, that's an array as well. So none of those are controlled. We're just saying there has to be at least one codable concept that has at least one coding that is vital signs observation category, or observation category vital signs, depending on which way you prefer to say that. So that's a pretty complicated set of rules, actually. We can start thinking about what we want that to look like. And we can say something like rule for observation and we're definitely doing it on observation.category. So that's pretty straightforward. We can do our normal things of saying not null. We can even do our cascade and do cascade mode stop, because if it's null, there's no way we can be meeting our requirements. If it's empty, there's no way we can be meeting our requirements. Now we need to try and dive into this codable concept and everything else to find all of these things. We could probably write a rule that would describe all of this, but we can do ourselves a little favor and build out kind of an extension on it. And so if we look at Fluent validation, and we'll start with the home page, and we can get to documentation somewhere. We'll just start here. There we go. There's a lot of things that we can add and keep building up onto. So in our case, what we're going to want to do is do a collection validation. And I think there you go, collections. Perfect. Yes, complex properties, collections. So it talks about a lot of different patterns you can use within collections. And so you could see, like in this thing for codable concept, we could do a rule for each. Well, it's a little difficult because what we really want to be doing is these nested any's, right? We're not saying every element has to have it. We're saying one particular element has it. And so it might not be terrible to dive through some of this and just say, what would that look like? Well, within category, we need a must. And do we have something that's similar? Must, list any. Yeah, that's close enough. So let's do categories. And the categories has to have any that meets this requirement. And within this, we need category such that category.code or coding has any that has, and this is why I was saying we probably want to put this into refactor this into something better. Any code.system is equal to our value. Oops, wrong language. And code.code is equal to our other value. All right, so this is what we could build out, and it's not perfect because coding could be null, so we can check through and do these, build these a little more complicated. Rule's not terrible. We can actually go and make these a little easier to read. If we do things like this, move this one here, move this one here. This one we need to change to US for vital signs dot this code system. And this code has to be the same thing, that we want US for vital signs dot Observation category vital signs. So that's a little clearer. And we can do something like this just so that it's lined up in a way that we can kind of see what's happening. So it's a little clearer, but this is a lot of code to write and pretty easy to mess up, particularly because this is a very common pattern. So we want to extract this. Again, the Fluent validation documentation talks about different ways you can do this. And in our case, I think we want to do something in here called something like concept list contains validator. That sounds pretty reasonable. We're going to need all of our standard things. I don't think we actually need this. We'll see. And we're going to go in our validation namespace. So let's look at what this looks like. Concept list contains validator. And the way you build these, and again, this is just from reading the documentation there, we can see, but we need some sort of T and T collection elements. And in this case, they're going to actually extend something called a property validator, which will be, and this is, again, this is just pretty much straight from documentation to do this. But we're going to add an additional requirement to say that T collection element has to be a codable concept. So what we're doing here is saying we're extending this property validator. And again, there's links to documentation, but we can see the property validator takes in the initial property and some sort of list collection element. So in this case, we're saying we're doing, for instance, here, we'll be able to call this with observation category, and category is a list of codable concepts. So we can use that here, and this collection element has to be codable concept. So these validators, again, I don't know quite how much we want to jump into defining how the Fluent validation works, but we can build this up as we go. Oops. So we're going to need to keep track of the system and the code we're looking for. So these, again, this object is going to be created as part of our validation. And so we're going to instantiate it and then apply it to different ones. So we'll probably grab these during construction. So we'll do a constructor that has them, and then the validation function will be a separate function, and that we'll get to here in a moment. Again, same thing, we could make this more generic and do either a system or a code or different things, but we don't have that use case yet, so I'm not going to worry about it. One of the things that we need to override is the name. We don't want to throw a not implemented, we want to say what this validator is called. And these are the things in the messages where those validators, the validator name comes through. And this is the same thing. So when we said there's the not null and not empty, these things that get formatted contain the name of the validator. And in this case, we want that to return concept list contains. Perfect. We do need our constructor. So let's create that. And we're going to, same thing, we're going to want our system and our code. But all we have to really do is copy them here so that we have them later. We'll just, this is not great commenting for this, but we won't worry about it. Okay, now the real meat of this function, this class, is a function we need to override, just like we did with name. but this one is this is valid. So this is the one that's actually going to be called on each element here to say, hey, is this thing actually valid? So just up here where we said we're taking in T and T collection, let's give this some sort of comment here so that this stops complaining and setting text validator to see if a list of codable concepts contains a value with a specific system info. Okay, so up here where we said these T and T collection elements, you can see these are getting brought down into here. So it's going to give us this context that we can use to find out things about where we are and the list of elements that we're actually checking against. So in order to, we can leave all of these things if not null and not empty here, or we can check them here. I like checking them here just from the point of view of it can't be valid if they are null or empty, and it makes our code a little bit easier to play with later. I'm actually going to change this name to concept list because we're working in here and this is a little easier for us to figure out. Just to keep track of, because we're doing lists and codable concepts and codes and all these different things inside. So if the concept list is null or the concept list is empty, so we don't have anything, then we want to return false, and we want to set some sort of message. So that's where we use this context, message formatter, append argument, and we can do something like does not contain, and you can see this message formatter. So this is the message that we're throwing when we say this is invalid. And here we're just going to give something pretty straightforward to say, system, and in FHIR we use that hash sign in code. Perfect. So, excuse me. So here what we're just doing is saying, the list obviously does not contain this system in code. We could pretty this up and make it nicer, but this will get us through for what we need. So, for each. Now, in our case, we know that concept list, it can be any collection element, but we've specified up here that this can only apply when the collection element is codable concept. So you can see here, we can actually just say every codable concept in the concept list. And even though it's doing this, the compiler is smart enough to figure out that collection element can only be codable concepts right now. So that's really nice that it lets us do that. We don't have to do any weird casting or anything like that. And it makes our code much easier to read. So here we want to do something different, because here now we're going to traverse this list and see what we have inside of it. Same thing, we're going to check to see if the concept has a coding or if the concept coding has any elements. If we don't have any of those, then continue. We're not going to check this codable concept because it doesn't have a coding. And this structure here is pretty awkward. Do I have one of these open? Observation. I have multiple observations. Doesn't look like it. I think we can click on this one. There we go, codable concept. So codable concept is hard because it just has this coding inside of it that is also an array. And that's where we have our system version code display everything. The reason for this is that you could say this concept has, for instance, a Loint code and a SNOMED code, and you want those two codings to be, they're representing the same concept. So we want to have those, or maybe you have a local system code, things like that. But they're the same concept. And in our case, the category can actually have multiple concepts. And so that's why we have this kind of odd nested structure that we're trying to traverse through. But we can make this somewhat nice to use. So in this case, and I think we have a lot of this over here already, we can just retype it for the formatting will be all different. So if we have a concept coding that has any, and that coding has a coding.system that's equal to our system, and that coding has a coding.code that is equal to our code, return true. And if not, we're going to do this same thing down here to say we did not find it and return false. Perfect. Now at this point, this is all functional, but we can add one more thing that is nice to do, and this is protected override string. There we go. That's the one. Get default message template. So here, when we're talking about message formatter, you can see these arguments. They actually get run through this template thing first, and we're just returning a string actually. So we can just do this and give it a string that we want to use. And this way, all of our messages get formatted nicely. So you can see it passes us an error code, and then we can add in some things here. So the first, we still want to keep our same structure that we're using everywhere else that has the default. But you see we can put a nice quotable concept, a nice message in here. And we can just copy this from here. So that way, all of our messages, period, whenever we have an error, it will add that this property name must contain a quotable concept with this code. Perfect. So now we have this validator, property validator that we want to use. The easiest way to actually do that is from extensions. And again, this is all documented on the Fluent validator. But let's add a file called validator extensions. And we'll go ahead and grab things we need here. And actually, let's grab the main space too to save ourselves a little type. Perfect. So we've used extensions, class extensions, not FHIR extensions, C# class extensions, pretty extensively. Nice. We've used those a lot when we were generating all these things on to create US Corp patients or blood pressures or different things like that. So this is just going to be the same thing. We're just going to make a class to hold our extensions. And then we need to, let's see, I have this copied somewhere. Yeah, close enough. There's the actual thing we want to do it on, and I think this is actually documented here. Inheritance, rule sets, dependency injection, custom validators. There we go. So in here, there is somewhere that you can grab what this, there it is, writing an extension. Perfect. So this has in custom validators, it talks about, has all of the actual class you need. This is because all the chaining that happens and everything else, what we're actually doing is on rule builder options, conditions, blah, blah, blah. So actually, why don't we copy the one from them so that we can see what it looks like. And hopefully get it formatted slightly nicer than this. And this was list must contain fewer than. We don't care about that. We want concepts list contains. And you can see this was taking a number And we want to change that to a string system and a string code. This is formatted terribly so far, but we will get it fixed. And let's clean this up. Perfect. And we typed a relatively nice comment here that we can just reuse. Class to all extensions. We don't care too much about that. And then we need to actually build this. So in this case, we're not doing a custom one in here. We want to do set validator because we already made a nice validator for that. And this is a concept list contains validator. And again, we have T and this ILST element. So we can just reuse those and pass our system in code. Perfect. The only thing is, since we restricted this in our in our function, it's complaining because it's saying this could have been anything, and now we're saying that it cannot be. This has to be a codable concept, and that should do it. Use expression bar. Okay. So it just wants us to do that. I don't know that I like that. This better. Okay. So what is it actually completing though? Cannot convert to Fluent validation, iRule builder, options, iList, okay. I'm wondering if we just need to build this. And see if that error goes away. What? This is the beauty of live coding. Return rule builder.set validator new concept list validator system code. This looks right to me. Public static. This fits into this iRule builder. Yes. Cannot implicitly convert Fluent validation.iRule builder options to Fluent builder options conditions. There we go. Copied over the wrong line of code, and there we go. Perfect. So this will just create this validator and then validate against it. That was a lot of work, unfortunately, much more work than we would like for what we were doing. But the nice thing is we only have to write that once. Now we can take this, all this must that we had before, and we can just say concept list contains. And we just need to give it a system and a code. So US core vital signs dot system, US core vital signs dot code. Oops. Code. We can even get rid of these, all of these other things, because this will check for them to see if that's empty or anything else. So let's see. We now should be able to do US core vital signs now. And let's see. US core vital signs validator looked right to me. This we create the abstract validator for observation. This is there. New expressions. Yes. There it is. Acting new. Very weird. Okay. There we go. Was just in a weird state. Perfect. So now, if we run this, we should get through our same thing we were doing before, which is to say validation passed true. So in here, we created the, since we were calling create observation. Create observation is actually using this US core blood pressure create function that we had. And it's actually setting everything up, and it does set the category, which is what we were checking here. So if we want to, when we look at, for instance, the validator, we can say plus fail. So now we're going to check to see if this invalid system exists. And we should see the validation fail. Perfect. And so now we can see the same message template we were doing before. And we could also remove that profile name if we want, or property name. But let's pull it up so that we can see here. So you can see validation issue, property name. That was output by our validator here in the program. There you go, failure.property_name. So that was our message. And then it has the error message. And the error message is this one we put here. Property name must contain a codable concept with a code matching this. So you can see that gave us this very nice thing of checking. In this case, we can see that this observation category fail. That will obviously not be what we were looking for. And it gives us a nice message that we can come back to and figure out. So let's get rid of that. And thankfully, now that we've written this extension, concept list contains, that's a pattern that shows up in a lot of places. And so it's not too painful to then reuse that. Perfect. So let's close that one. We don't need it. Do we have anything else we need to validate in vital signs? Everything else is just valid FHIR. That looks like the only thing we really care about. So we'll copy this because we want to create our blood pressure one. That's another US core blood pressure validator.cs. So we can take this one more step, because just validating one element is not great by itself. We can do a little bit more. So let's make sure that everything we have is correct here. Let's grab our URL, paste it in here. Blood pressure validator it is against observation, so that's good. And US core blood pressure replaces US core vital signs. Perfect. So the first thing we want to do in blood pressure isn't check this. Well, it is check that. We want to make sure that we're conforming to vital signs. So validate against US core vital signs. And again, this might have additional rules, especially over time as you build things up or add business rules, then we can do that. So what we're actually going to do is put a rule for observation on observation itself. And that rule is going to be set validator to a vital sign code. And so what that'll do is say, the observation itself, go ahead and make this validator and validate against it as we're doing everything else. So that's pretty straightforward, and that's, you can see how we can build up these layers on top of each other. So what do we have? We have similar things here. We want to also check the observation code, and we want to see if this has. Now, this is a little more interesting. This is not a concept list anymore. This is just a single codable concept. So we're going to have to do the same thing that we just did, but we're going to do it on a concept instead of a concept list. Now, the nice thing is we can just take our concept list contains, copy it, do concept contains validator, paste it, and fill in all of the same code. All we're going to do is, instead of T collection element, this is going to be a concept contains, this is going to be a T element, this is going to be a T element, and this T element needs to be here. Let's see if a codable concept contains a value of code. That all seems right. And we're going to do the same thing. Just put this through. This is a pretty straightforward set of changes. This time, instead of taking a concept list, we're going to take a T element, which is a concept. And same thing, we're just going to check to see if, oops, the concept is null. Return false, and now we're not traversing these, we're just doing this. So if there's no coding, then we want to fail. And if there is one, we pass, and if not, we fail again. And yeah, that's it. And then we do the same thing in our extensions. We can just grab this, and this same thing. We're just going to do a T element, and concept contains, and this is an I rule builder on T elements, system code, where T element is a code of concept, and then we just do concept contains validator, system code, and we're going to grab this same message there. Perfect. So much less painful the second time through, and then we can come here and add our rules that we were going to add, which in this case is the code we were looking at. So we want the same thing. We want the rule for observation. We want observation.code. And now we can just say concept contains. And I think we just passed, yep, the system in the code. So we have US for blood pressure dot, and here we can see, I don't remember which one it was off the top of my head. This is a LOINC code for blood pressure. So URL code system LOINC and US core blood, oops, US core blood pressure dot blood pressure panel. And we can add nice messages behind all these if we want. I don't remember if we did that in the vital sign validator. No. Our messages are pretty good on this type of thing. The concept contains already, so we don't really need anything additional. Let's see. So that takes care of observation code, and then component. You can see now this is the fun thing here. This is the same thing we were saying. Components now is a backbone element, and it's going to have the same thing. We want to check to make sure there is asystolic and a diastolic, and that those all meet the requirements that they have. So in this case, these are all the same because you can see they are, if we have a quantity, it needs to have all these other things, and it needs to have that matching value. To build these out, unfortunately, this isn't like we had before that it was a codable concept. This is just a random backbone element within it. So we're going to have to build this out, at least to start with. And let's see what happens. When we look at observation.components, we're definitely going to want the same thing, cascade mode.stuff, because we're going to add our same not null, not empty rules that we always have. And now this is going to look like that first set of things we did. We're going to take in the list, and we're going to say that that list has to have any, and we're looking through components. And that component needs to have components.code.coding that has any coding. And you can see this is why the definitely generating all this code is going to be a lot nicer. Oops, we need code dot. Oops, that's why code dot. I want to make sure that I say what I'm doing and do what I'm saying. So here we're going to do the same thing. We just need to do US core, blood pressure, URL code system link, and we need to make sure the coding.code is US core, blood pressure, systolic first. So, okay, yes, the drawback of Fluent validation are all these extra parentheses. We could break these into additional rules, but the big problem is that a lot of the validation wants to validate every element of an array, and here we're just trying to validate one element of an array. And so we probably actually need to do something more, something first here to say, because here we're nesting twice. So if we looked at the component and the code was null, this might cause a problem. So we'll want to do some testing, but we want to get the flavor of what we're doing. In this case, we definitely want a message though. In that message, we probably want to be something like US core blood pressure requires a component, and then we want to pass through our same message just to keep the same format that we were doing before, and say we have to do this. So we could build up a set of rules just for this component. The problem is that it's just following through these strange code paths within this element. So I kind of want to highlight the difference. Before we were doing things on codable concept, so it makes sense that we can build out things on codable concept, but here this backbone element means it's just a random structure of internal type. So we could go through and build an extension method, but it'll only be useful in this exact one place. So it might not be terrible to build out this same type of validator within US core blood pressure, but looking at how much time we have used, I don't know that that's going to be the kind of thing we want to do today. And here we're just going to do the same thing and say we need white code diastolic. Now, here's where it might be nice to not have the cascade mode stop. And the reason being, if you're missing both of these, it would be nice to be able to see that in one shot. So let's check this first to see if it runs. And I'm going to remove those just, again, we'll keep tinkering with this shape. But I want to be able to show this here, the big difference. If we come here and change, code plus error, and we're going to do the same thing on this next one. And now, because we're not using our that class model. We could change it here in the error messages too, but I'm not going to worry about it. This is just to show what happens. Validation passed. Huh. So we definitely have an error somewhere because this definitely should have failed. Okay, what we're saying is observation component is a list, and that list is going to check for any component such that the component code coding meets one that has this code system and this code. And this code system should never appear because it's yelling about that. Let's see if it's something that simple. I don't know that it is, but let's see. No, it's still passed. So we're saying that this has a system of loink plus error, and that it has a code of systolic plus it has that. I don't believe it. So we definitely have an error somewhere here. Let's see what happens. If we are looking at observation.component, so let's look, do we have this in our resource.json? Nope, this is the patient. We can debug this further. So, of course, we run into these errors right when I'm wrapping up. So, at this point, observation components, we take in a list of components. We check that list has any components that has component code coding and blah, blah, blah. That all looks correct to me. So if we look, and this again is the joy of live coding. Sometimes these things happen this way. We can just add right here, validate official. And then it will, oops. This is because this is supposed to be a resource. Do that. Perfect. This way we can see our output a little easier. So if we look in resource.json, we can see we have a category that has a coding that has this system and this code. Vital signs, okay, those were working. This we're looking at components. We want a code that has a coding that has this system and this code. So this is what we're trying to test against. And when we're in here, we are looking at components. That's components, that is correct. We are checking for a component that has a component code coding that matches those two. So, trick here is we are throwing this with an error. Let's actually just remove this altogether. That is the code we want, the system we want. So we definitely are looking for something invalid in our system. And that should not match any of the codings we have here. Oh, you know what? We are using a vital signs validator. We want a US core blood pressure validator. And that shows the kinds of errors that happen to all of us. There we go. So, in this case, that is working correctly. And we can see, since we were checking against this invalid, without Cascade, we can see both errors. If we turn on Cascade to stop, then we'll only see the first error. There we go. So here we see the first error, but even if we fix this, so we come back here and say US core blood pressure dot loink. So the first one passes. We went through, made a bunch of code changes, fixed everything, and then we still see the second error. So in this case, I think having the cascade mode off is better. Perfect. So to be clear, just to clarify what was happening, this code was all correct. We just weren't calling it. We were still using the initial vital signs validator here, and that was the only thing I missed there. And that's the process of debugging. So, yeah, I think given how long this has gone, probably that is a great place to stop. We've built up a couple of more patterns in Fluent. We've built up the extensions for the concept list validator, concept list contains validator, and the concept contains validator. And those will be generically useful since codable concepts appear all over the place in profiles. And then we built out these kind of complicated rules that we can use for slicing within backbone elements. And we can always continue to refine those and see what else we can build better. But that's a great place to stop. So if you have any comments, questions, anything, please let me know. And if not, we will see you next time. Cheers.